All right, hey guys, Mr. Kyle Myers Mathematics, and let's just jump into it. I'm going to do a whole series on series, so I'm just going to call it the series. And there might be some series puns along the way. I don't know. We'll see. But I'm just going to go through all of them, and this is coming from the Stax textbook. So I figured I would do that one because I have calculus textbooks, but I was like, well, yeah, but I could have one that's different from yours, and then you could have one that's different from somebody else's. So how do we get on the same page? How do we practice the same problems? Well, OpenStax is free, so you just openstax.com or whatever, or just Google it, and then calculus 2, and then I'm on section 5. So you go to section 5.1, and this is number 1 on section 5.1. Should be the same no matter what. So even if you have a different book, we can still be on the same page. So hopefully this series will be really helpful. And let's go ahead and jump in. So number 1, we're going to find the first 6 terms of each of the following sequences, starting with n equals 1. So n equals 1 is pretty typical for a sequence. For a series, it's also pretty typical, but sometimes you also start at 0. 0 and 1 are by far the most common. It could be something else. It could be 2, 3, or 4, but 0 and 1 are like by far the most common. And for sequences, like 90%, you're going to start at 1. So if they don't tell you where you're starting starting at 1, unless they say otherwise, basically. That's like the default assumption. So with that, all we really need to do here is just a little bit of PEMDAS. You can actually kind of figure out the pattern as you go, and then and kind of get it from there. But the first 6, so we'd start off with A1, and that's just going to be 1 plus -1, and then I plug in 1 for n. So that's just going to be 1 plus -1, aka 1 minus 1, which is 0. Not too bad, right? All right, well, let's see what A2 is. And then we'll see if we can see what the pattern is. So 1 plus -1, 2. The only n in A sub n is the n in the power, so that's the only one. 1 plus, and then -1 squared would be +1. 1 plus 1 is 2. Okay, A3. 1 plus -1 cubed. -1 cubed is -1. So that would be 1 plus -1, which is 1 minus 1, which is 0. And now, hopefully you can see that pattern. These two are the same. Because it cycles. If I'm counting by ones, if n goes 1, 2, 3, 4 all the way to infinity, any odd power is going to make it be -1. -1 to any odd power is -1, and then -1 to any even power is +1. So basically, I can tell you what the next terms are going to be without really having to do the math. The 4th one is going to be the same as the 2nd one. That one's going to be 2. The 5th one is going to be 0. And then the 6th one is going to be 2 as well. Hopefully you can see that. I'll move it just a little bit. Yeah, that's better. Okay. And there we go. We've got the first 6 terms. And hopefully your professor doesn't need to see the work for all of them, because this is Calc 2 after all. I mean, if you can't add 1 and 1, then why are you in Calc 2? But so hopefully the professor isn't too nitpicky that he or she needs to see like all the work for this. Hopefully they give you extra bonus points for like showing some work, that you're not just like, you didn't just type this into ChatGPT or OpenAI or something. But at the same time, like seeing like, okay, hey, math is all about patterns, especially sequences and series. So I noticed a pattern and I just extrapolated and got the last 3 answers without showing any work for those. So hopefully that's where you land. If not, then you could just do exactly this. And then I'm sorry, maybe you just chose the wrong professor. But yeah, so that's the goal is, and hopefully the next few videos, I'll keep straight to the point and not come back to all of the intro stuff. Sorry, all of the intro stuff. But I started it, and then we had a baby, so that happened, and I didn't plan ahead on content. I only planned like 1 week ahead, and then I was like, oh, hey, it's been a week, and I'm still not sleeping. So, but we are back to doing a series on series. I'm going to go through all of them. And the goal is to do one every day, minus like Sunday, but maybe I'll just like schedule it so that it comes out on Sunday because I just don't work on Sunday. But that's the goal. So check back in on 2, 3, 4, so on and so on, and then on if you're on section 5.2 or 5.3 or 5.4, and maybe you're watching this video and this video is old, well then maybe I have already gotten to sections 5.2, 3, or 4. So check those out. Or if this video is fresh for you, awesome. Stick with the series on series, and we'll get to whichever one you're on. Or if you're on 5.1, it does get a little bit harder, but there's once you know all of the tests, there's a little bit of memorizing, but like once you know the tests, there's 10 altogether. 10 tests for series. Once you kind of like know all 10, it's really helpful because you kind of just pick from whichever one fits the best. And if you're not sure, you can just pick one and then it either works or it doesn't. So really, I would say the hardest part is just like knowing all of them, because it does take a while to remember 10 different tests and like the details of all the tests and stuff. But hopefully there's a formula sheet. But in the meantime, I can show you a couple ways that you can like get the gist of the test without memorizing all the nitty gritty just yet, and work on it from there and whatnot. But already I think it's been a little too long. I wanted to give you an intro on the first video, but as we go, we'll just kind of knock the problems out, so the rest of the videos will be a little shorter. So hope to catch you in the next one, and hopefully this series on series will be helpful for you. Blessings.